step. You can't find the second unless you find the first. So what's the derivative of x squared with respect to x? 2x. Plus, what's the derivative of y squared with respect to x? 2y. Y prime. What's the derivative of a constant? 0. So we manipulate this to solve for y primed. So I move the 2x over, it becomes negative, divide off the 2's. I get negative x over y. There's your first derivative. That's not what I want. I want the second derivative. So take the derivative of that. So we go, okay, what's the derivative of y primed with respect to x? Y double primed, right? It's just y double primed, you're taking the derivative of it. So I get y double primed is equal to, now it gets fun. Why do you always cringe when I say that? What rule do I need to use here? Quotient rule. So quotient rule says the derivative of the top function. What's the derivative of x with respect to x? Minus 1. Well, yeah, minus 1 in this case. So we get minus 1 times the bottom function, which is y. Subtract. What's the derivative of y with respect to x? Y primed. Times the first function, which is negative x. Divided by the bottom function squared. Are we okay? Okay. Let's just clean up these negatives for a sec here. So I'm going to get y double primed is equal to negative y. Those two become positive x y prime over y squared. Okay. What's wrong with the way this is right now? You got a y primed and a double and a second derivative in the same equation. We don't want that. But what do we know? What's y primed? It's that. So we can sub this in for y primed. So that gets subbed in right there. So now we get y double primed is equal to negative y plus x times negative x over y squared. Now it's just an algebra problem to clean this up. So negative y, I'll pull that negative out, minus x squared over y squared. I still have everybody. Yeah? Okay. Okay. This is a complex fraction. What do we do with complex fractions?
We don't like them.
Okay, but what do? We don't. You're right. We don't like them.
Beat
But
them up.
how do we beat them up? Sorry. Okay. How do we simplify them?
I would take away the y under the x squared and put negative y squared negative x to the second over y to the third.
We just did a lot of stuff in your head
What
there.
she said, yeah.
You are correct. So, sorry? We're going to do what she said, but we're going to do it in a few steps, not in one step in her head. We're going to make a common denominator for the top. Okay, so I'm going to multiplied by y over y. It's going to give me negative y squared minus x squared all over y squared.
Why don't change
Hmm?
y to the power of negative 2 times the whole thing?
We're going to do that in a sec. Then you're going to flip and multiply because we don't like fractions stacked upon each other. Y squared is 1 over y squared, which gives me everybody follow that move? There's one other move we can do. If you take a negative out of the top, you end up with y squared plus x squared over y cubed. Why does that help us? X squared plus y squared, if you look at the original equation, equals 25. So that simplifies down to negative 25 over y cubed. Second derivatives implicitly can get a little gong showy. All right? Okay, so if you're doing the second derivative, do the first derivative. You're probably going to sub in at some point, and then you're going to clean it up, and then just check to see if the original function pops out, and if it does, sub back in. It's more algebra than anything, okay? I'm just going to give you a few questions, 45 to 49. There was questions in the video yesterday, right? Okay, perfect. If you need more practice doing those, do those questions if you haven't done them already. Then these. Monday, should we do some sort of groupy thing? Yeah? Okay, group quiz Monday. There you go. We're coming near the end of the unit, so we only have one thing left, which is related rates, which is word problems.